Welcome to a couple of examples on the substitution method with regards to integration. I have here on the screen, an epidemic is growing in a region according to the rate of n prime of t is equal to 100t divided by t squared plus 2, where n of t is the number of people infected after t days. We first want to find a formula for the number of people infected after t days, given that 37 were initially infected. So this will be the integral of 100t divided by t squared plus 2 dt. And for our substitution, we're going to let u be equal to the denominator, t squared plus 2, and the derivative of u, du, would be 2t dt. So when we plug this into the substitution, since we have a 2 here in our differential on here and a 100 in this numerator, we're going to divide 102 to get 50 times the integral of u to the negative first power du. And when taking that integral, we would get 50 times the natural logarithm of the absolute value of u plus c. And just reapplying that substitution, this is 50 times the natural logarithm of the absolute value of t squared plus 2 plus c. And that's the function for n of t. But we're given that the initially 37 people were infected. So we are going to set 37 is equal to 50 times the natural log of the absolute value. Since it's the initial infection amount, this would be when t is 0. So 0 squared plus 2 in the absolute value bars for that natural logarithm plus c. And this solves that value of c to be about 2.3426. So this function of n of t is given by 50 times the natural logarithm of the absolute value of t squared plus 2 plus 2.3426. And then based on that, to find the number of people infected after 21 days. So n of 21. This is 50 times the natural logarithm of the absolute value of 21 squared plus 2 plus 2.3426. And that makes about 307.02 involving these particular values. The next one that I want to do on here is this one. The marginal revenue in thousands of dollars from the sale of X MP3 players is given by R prime of X is equal to 4x times X squared plus 27,000 to the negative 2/3 power. And we want to find the total revenue function if the revenue from 125 players is 29,591. So we are integrating 4x times x squared plus 27,000 and dx from this. So, and this is raised to the negative 2/3 power. Let me just put that on here and give myself more room. So to the negative 2/3 power dx. Okay. So to find that integral, we're going to use the substitution of u is x squared plus 27,000. And du would just be 2x dx. So from this, we're going to take the 4 and divide that by the 2 and the differential on here. So we would multiply this integral by a value of 2 times the integral of u to the negative 2/3 du. So when we add 1, we get 2 times negative 2/3 plus 1 is 1/3. And since we have to flip that, this will be times 3 times u to the 1/3 plus c. And that simplifies. It simplifies a little bit to be 6 times u to the 1/3 plus c. And based upon the function that we have, this would be r of x is equal to 6 times, resubstituting back in, this would be x squared plus 27,000 raised to the 1/3 power plus c. And to get the value of c, we need to plug in this 29,591. Since the marginal revenue is in thousands of dollars, we're going to write this as 29.591 is equal to 6 times 125 squared plus 27,000 raised to the 1/3 power plus c. And this would give us a value of c, once we evaluate and solve, to be about negative 180. So the full revenue function r of x would be 6 times x squared plus 27,000 raised to the 1/3 power minus 180. And then how many players must be sold for the revenue to be at least 40,000? Again, same idea. We're going to set 40.000, so just 40, is equal to 6 times x squared plus 27,000 raised to the 1/3 power minus 180. Solving for x for this, we would get a value of about 150 units. And then the last example I wanted to do is this one. Evaluate this indefinite integral, the integral of x cubed times the square root of x squared plus 22 dx. We're going to set u to be x squared plus 22. And we're going to take the derivative of u to be 2x dx. But since there's no 2 in this, we're going to divide both sides of this by 2. So we have a half du is equal to x dx. But because of this x cubed, we're going to factor out. We're going to factor out an x. So doing so, we get x squared times x times the square root of x squared plus 22 dx. So to actually solve this, we do need to do one more operation here. And that's to solve this original substitution for x squared. So x squared would be equal to 22 minus u to solve for that x squared. And so we could then use that in our substitution here to help us solve this. So this would be equal to, this would be 1/2 times the integral of, since we have x squared here, that would be 22 minus u, times u to the 1/2 du. And we first need to distribute that u to the 1/2. So this would be 1/2 times the integral of 22 times u to the 1/2 minus u to the 3/2 du. And this makes 1/2 times, this will be, we have a 22 here, times Adding 1 to the 1/2 makes 3 halves, and dividing by 3 halves is the same thing as multiplying by 2/3 times u to the 3 halves minus 3 halves plus 1, so 5 halves. Flipping that, we get 2/5 times u to the 5 halves plus c. And so we can slightly simplify, multiply by this 1/2 and whatnot. This would make 22/3 times u to the 3 halves minus 1/5 times u to the 5 halves plus c. And then finally, resubstituting back in, we get capital F of x here to be 22/3 times x squared plus 22 raised to the 3 halves power minus 1/5 times x squared plus 22 raised to the 5 halves power plus c. Let me know if you have any questions or concerns. Thank you.